Hi everyone, so this is for the lesson about advantages and disadvantages of series in parallel connection. You have to remember the following terms and situations. First, series circuit is a circuit in which resistors or loads are connected end to end so that the circuit will have only one path through which electric current flows. Second, parallel, when the end of each of the resistors or loads have a common point or junction and the other ends are also connected to a common point or junction. Third, voltage drop is proportional to the resistance current being the same throughout the circuit. These are examples of series and parallel circuit connection. You'll see on the right the parallel circuit. This is actually connected, and please look at how it is connected to each other for the circuits. And for the series circuit on the left, you'll see how they are connected to each other in a line, or in, of course, the resistors connected to each other. You have to take note that if the cells are connected in series, the voltage of the battery will be the sum of all the cell voltages. For example, a 12-volt car battery contains 6 2-volt cells connected in series. Some vehicles, such as trucks, have two 12-volt batteries in series to feed the 24-volt system. This is an example of a parallel circuit connection. You'll see that the voltage is actually on the battery, and then you have there two resistors, okay, acting as the, of course, parallel, okay, circuit connections. So you'll also have to see on the right are the symbols and how they're connected in a parallel circuit connection. In this illustration, you're going to see the comparison of series circuits and parallel circuits. So on the left, you'll see the series circuits. I guess I'll take note of how they're connected to each other, especially the valves and the wirings. So on the other side, or the right, you have the parallel circuits. There are three light bulbs, and you have to take note how the wirings are connected to the valves, and so that they can be able to work. You can see in this example the difference of the series circuit and parallel circuits in terms of the battery or the voltage. So you have three batteries, and they are all have the same voltages, which is actually 12 volts. So the output, okay, will have 12 volts. On the series circuit, you'll have three batteries there having the same voltages, so 12 volts, and the output will be 36 volts. So that's the difference, again, in terms of the comparing of the series and parallel circuit. What are the characteristics of series circuit? Number one, a number of resistors are connected in series. The effective resistance, or the total resistance in the circuit, is gotten by adding the individual resistance. Second, series connections. The same current flows across all the branches of the circuits, but different voltage across it, thus making the resistors to have different voltage across them. Each resistor or load will experience a voltage drop. Number 3, voltage drop is proportional to the resistance current being the same throughout the circuit. The fourth characteristics of a series circuit is that its loads will tend to have a common switch. Fifth, when a load develops a problem, the other connected system will fail. And sixth, a blackout can happen when one of the connection fails to deliver the energy. Alright, so for the opposite of the characteristics of a series circuit, we have here the characteristics of parallel circuit. First is that when finding the total or effective resistance in a parallel circuit, the reciprocal of the individual resistance is taken. Second, we can control other wirings in the circuit. Third, it can have multiple switches. And fourth, its electricity can still flow to other wirings. This illustration is showing us the voltage rise and voltage drop. So what is the difference between these two is that the voltage drop, as you can see on this illustration, that from the flow of electric current towards the resistor, so the voltage will drop. On the other hand, you will see below the illustration wherein the resistance actually flows from the resistor towards the electric flow of the current. So this is opposite. So of course it will have the voltage rise. Okay, so this is the difference when we actually put a resistance and the differences in terms of where the flow of electricity goes through. It's either away from the resistor or towards the resistor. So if it is towards the resistor, of course the voltage will drop, and on the opposite of that, wherein the voltage rise will happen when the current or the flow is coming from the resistor towards the electric flow of the current, or the I. Alright, so let me help you regarding safety devices at home. And to understand it better, you have to remember that there are two hazards in terms of electricity. The first is thermal hazard, occurs when there is electrical overheating. And the second is the shock hazard, occurs when electric current passes through a person. Another term is the circuit breakers. It functions to break the circuit when the current is in the circuit exceeds the maximum value. It is no longer considered safe. To do this, there is an electromagnet that can physically break the circuit when it detects that the current has exceeded its maximum. One of the terms that you have to remember about safety devices at home is the fuses. Of course, fuses are like circuit breakers in that they will break a circuit when it detects that it is too dangerous to operate. Fuses are actually resistance, that of course uses a low melting point instead of an electromagnet. And when the current is too great, the wire melts and the circuit will be broken. As the fuse melts every time the current is too great, it can be replaced, unlike the circuit breaker, which can be reset after it breaks the circuit. These are examples of different types of fuses, so you can replace them when they are already broken. So this can make your appliances at home safer. Okay? And of course, it controls the flow of electricity towards the appliances. Additionally, these are examples of fuses. In continuation about the terms, the second that you have to remember is the earthing. So there are three wires that supply power to households. These are the active, neutral, and earth wires. Earth wires are put in so that electric shocks can be avoided when people come in contact with an active wire that is in contact with the casing of the connected appliances. If there was no earth wire, a person would complete the circuit between the appliances and the ground and would receive an electric shock. In continuation, you also have to remember that to reduce the chance of this happening, or as mentioned a while ago about the electric shock, the earth wire provides a better conductive path for the current. If the current comes in contact with the casing of an appliance, the earth wire will create a conductive path from the appliance to the earth, and a large current will flow to the earth through this connection. This large current will also blow any fuses or trip any circuit breakers, so that the circuit is not complete, and any person touching the appliance will not receive an electric shock. These pictures are examples of the earthing, okay, versus the grounding. So you can see on the left picture is the earthing. Okay, so maybe you know regarding the connections of this to your appliances, especially for example the washing machine, okay, and other appliances that you have at home that needs earthing. So another is the grounding, as you can see here, right? So this actually prevent from actually receiving a person for electric shock. Another term that you have to remember is the double insulation. So insulation is installed so that wiring and electric appliances are covered, so that the current will only go through its intended path. The insulation is made out of an extremely poor conductor in order to create a safe path for the current to flow through. To increase the safety from insulation, a second layer of insulation can be installed, so that if one of the layers fails to properly insulate the circuit, the second layer will be able to protect it. This picture shows an electric cooker as an example of appliance at home, wherein the person is holding it. It avoids the electric shock because the wirings like the live, neutral, and earth wirings that were mentioned a while ago are connected in the casing. Okay, so of course it helps a lot not to provide any errors, and to help the person avoid the electric shock. The last thing that you have to remember is the residual current devices, or the RCDs, are designed so that they can stop a current before it becomes harmful to a person. It does this by detecting any leakages from the circuit through a differential current transformer that will compare the current flowing through the live and neutral conductor. And if there is a difference, it quickly shuts down the current. It typically shuts it down in 25 to 40 milliseconds after a leakage conductor to minimize the damage done to the body. This picture shows an example of a residual current device, or the RCD test. That's all about this lesson. Thank you so much, and hope you learned a lot.